In this packet of notes, we are going to be doing two important things. First of all, we are going to be building the unit circle. And secondly, as we build the unit circle, we are going to be computing the exact values of the 6 trigonometric functions, meaning sine, cosine, tangent, cosecant, secant, and cotangent of the angles that appear on the unit circle. All right, so there is a lot of important information in this packet of notes that you have to kind of know backwards and forwards. Okay, so we are going to start by building the unit circle. So first of all, we are going to talk about what the unit circle is. Okay, so if you read the first bullet point there, it says the unit circle is a circle whose radius is 1 and whose center is at the origin of a rectangular coordinate system. Okay, so important definition there. Okay, so if we scroll down, there is a picture of the complete unit circle. Okay, so again, very important, okay, from what we just read. So you've got a circle, okay, it is centered at the origin of the XY plane, okay, so the origin 0, 0, this is going to be the center of the circle, okay, and also very important, the radius of this circle is 1, okay, so meaning the distance from the center of the circle to any point on the circle. So for example, this distance right here, that's the radius, okay, that radius is 1 unit. Okay. All right. So if you look, this is the complete unit circle. Okay. It's very busy. There's a lot going on here. Okay. So what you should see at a first glance, you should notice there's a lot of angles. Okay. The angles are given in both degrees and radian measure. Okay. And then also what's going on here is you have a bunch of points that are called out on the unit circle. So for example, consider this point, okay? That point that I circled in red, that's a point on the circle, okay? So what you see next to the point is an XY pair, okay? So you see the X coordinate and the Y coordinate, okay? So what this is saying, okay, is that for this particular point on the circle, okay, these are the XY coordinates of that particular point, okay? This is where that point is located in the XY plane, okay? So you see that for all these angles on the unit circle. You see for these particular points on the unit circle, you see the angle, okay, that it's located at, both in degrees and radians, and you see the XY coordinates of each of these points that are called out on the unit circle, okay? So again, a lot going on, okay? So if you read below, okay, it says, the unit circle is without a doubt the most critical topic a student must understand in trigonometry, as the unit circle is the foundation on which trigonometry is based, okay? If someone were to look at the unit circle shown above and try to memorize it, they might find it difficult, okay? So here we're going to discuss how to construct the unit circle and exactly where all these numbers on the unit circle come from, okay? So what you should get from that statement, the unit circle is ultra, ultra, ultra important in trig, okay? You are going to be using the unit circle throughout this class. It is something you have to know backwards and forwards. It is something you need to commit to memory, okay? It is not going to go away, okay? If you move on from trig to pre-cal, the unit circle will still be there. If you move on from pre-cal to cal, the unit circle will still be there. This is something you've got to know going forward in your math journey, okay? So you need to commit it to memory, okay? So what that statement was saying, yes, you can try to just purely memorize this thing, okay? But since there's so much going on the unit circle, okay, you may forget some aspect of the circle or mix something up. So it's in your best interest to understand where all these numbers are coming from, okay? So that is the goal of this section, okay? To build this thing from scratch so you can see where every single number on the circle is coming from. That way, if you forget something, you can kind of reconstruct it if need be, All right, so in building these things, I want you to keep some little details of the unit circle in mind. Okay, so let's scroll below the circle again. Okay, let's take a look at this particular bullet point there. Okay, it tells you the equation of the unit circle is x squared plus y squared is equal to 1. Okay, so that's something that you can kind of keep in the back of your mind. Okay, let's go up here and talk about this. Okay, if you have taken college algebra, particularly 13, 14 here at UP, there is definitely a section that we cover about circles. Okay, um, if whether or not you've taken that class or not, you may or may not know that the equation of a circle is this. Okay, any circle has the equation x minus h squared plus y minus k squared is equal to r squared. Okay, so that's just the generic equation of a circle. And when you plug into this formula, x and y stay x and y. K, or sorry, HK is the center. These are the coordinates of the center of the circle. And then R is the radius of the circle. Okay, so here for the unit circle, okay, the center is at the origin. So 0, 0 is the center, and the radius is 1. Okay, so you could plug that information into the generic formula for a circle. Okay, I always tell students when you're plugging into this formula, you can kind of think of this as the template. Okay, when you're plugging into the formula, x stays x, the minus sign comes with it, y stays y, the minus sign comes with it. Okay, and then each of these guys is squared. Okay, you're adding those things together. Okay, on the other side, you're getting the radius squared. Okay, so when you're plugging into this equation for a circle, okay, this is kind of your template. Okay, you're plugging in the h, the k, and the r. Okay, so if you did this, okay, h is going to be the x coordinate of the center. Okay, so 0 is going to be the h, and then k is the y coordinate of the center. So k is also 0. Okay, so this would turn into x minus 0 squared plus y minus 0 squared is equal to, then you've got to pop in r squared. R is 1 here. Okay, so if you simplify all that, okay, that's going to give us x squared plus y squared is equal to 1. Okay, so that's where this equation of the unit circle is coming from. Okay, so you might want to keep this in the back of your mind. Okay, the equation of the unit circle is x squared plus y squared is equal to 1. Meaning if you take any point on the circle, okay, it's going to have an x coordinate and a y coordinate. Okay, and that xy pair has to obey this law, that if you square the x coordinate and then add the square of the y coordinate, it should equal 1. Okay, so that's some good information to know. Okay, what else? We know, so if we look at this bullet point, it says we know that any circle of radius r has circumference of length 2 times pi times r. Remember, the circumference is the distance all the way around the circle. Okay, so therefore, since the unit circle has a radius of 1, its circumference is going to be 2 times pi times the radius, which is 1. So the circumference is just going to be 2 pi. Okay, so the length all the way around the circle is going to be 2 pi units. Okay, so remember that's just going to be this blue length. Okay, the length all the way around the circle, okay, is 2 pi units, whatever length is being measured in. Okay, and then there's another way we can think of that statement in terms of arc length. It says, in other words, for one revolution around the circle, the arc length is blank. Okay, well, remember, if we are dealing with the unit circle, okay, in the unit circle, all of our angles will be measured in standard position. So meaning every angle is going to have its vertex at the origin, and the initial side will lie along the positive x-axis. So if we did one revolution, so if we rotated 360 degrees, the arc that would be intercepted by that angle would be the entire length of the circle. Okay, so the arc length of one revolution would be equal to the circumference here, the distance all the way around. Okay, so it says one revolution around the circle, the arc length will also be 2 pi because it'll be equal to the circumference here. All right, so those are some good little tidbits to keep in mind as we go through building the unit circle. Okay, so here we go. Here's one last look at it. Okay, and our goal walking throughout this packet of notes is to see where every single number comes from here. Okay, we are going to start building the unit circle by taking a look at how or where the angles come from. So let's take a look.